Dear all, a very good day. In the previous lecture, we have looked at X-ray based computed tomography and its basic principle of working. Here we are going to look at the different components which are included in that basic CT scan based tomography. Okay, this system basically consists of four major subsystems. First one being the scanning system, second one being the processing system, third one being the viewing system, and fourth one being the storage system. Now in the present lecture we are going to focus only on the scanning system, as scanning system have developed a lot in the past, and there are at least 5 generations of scanning systems that have been utilized so far. Okay, now let us look at what a scanning system is and what are its different generations. So scanning system, it takes suitable reading for a picture to be reconstructed. This include X-ray sources and the detectors. Okay, this means if we want picture to be generated by focusing the X-rays on a particular point and rotating the X-ray and the detector. Okay, so if we have higher number of readings, image will be much more clearer. Okay, suppose if we are focusing on the human lungs, which is in a particular plane in our body, and we are taking images from all around our body. Okay, front, back, left, right, and all the 4 positions between them, then we will get 8 images, and combination of these 8 images will give us the particular final image. However, if instead of taking 8 images we are taking 18 images, or even increasing the number or taking suppose 80 images, then reconstructing the final image, this will give us a much more clearer picture. So depending upon the reading also, it depends how we can improve the quality of our imaging which has been generated through CT scanning. Okay, so this is about what has happened over the period of years from our first generation to 5th generation scanning machines. Okay, so let us take a look at these different generations. Now first generation, it was also known as parallel beam generation. The X-ray sources moved in a straight line and 180 readings are taken. Then the whole system is rotated by 1 degree and again 180 readings are taken. Okay, and total we rotated by 180 degrees. Okay, so the particular body part which was to be scanned, human was laid on a particular table. Then this extra at a particular angle, X-rays were focused on the body and 180 readings were taken. That is 180 times it was observed what is happening in that part. Then the system was rotated by 1 degree and again 180 readings were taken, and so on. We made a complete semicircle and we took 180 readings in each degree. Okay, so total scanning or total scans that we were taking were 180 into 180 scans. Okay, now the tube and the detector moves in a straight line and sample data 180 times. At the end of each degree, a tilt is made and a new linear scan begins. Okay, this assembly travels 180 degrees around the patient. Okay, then this arrangement is also called traverse and index, but this was a very slow procedure and required a scan time of about 5 minutes. That was a very big disadvantage of this particular system. Then in the second generation we utilized fan beam and multiple detectors. Okay, it was an improvement over the previous system arrangement and consists of bank of detectors and a fan beam of X-ray. Okay, so we had a complete line of detectors here, each detector for different angle, and this was the X-ray source here. Okay, this still efficiently takes several profiles with each traverse and permits greater index angles. So we can use greater index angles and scanning higher number of images. So if there are 18 detectors in an array, a total of 18 traverse for 180-degree reading was required. So the traverse angle would be 10 degrees. Okay, for example, using a 10-degree fan beam, it is possible to take 10 profiles at one interval. Okay, with each traverse and then index through 10 degree, taking the next set of profiles. So if we had suppose an array, then X-rays focused, and all the 10 of those arrays record the data. Okay, then we move by 10 degree, and again in a different direction those 10 arrays record the data. In this way, what was done for a particular 1 degree at a particular time, that was completed in the same time we were able to scan 10 degrees. So this was a very great advantage over the previous technology, as it saved a lot of time. Scan time is approximately 1 second for each traverse, and then the system operates in 18 to 20 second range. So earlier what we were doing in 5 minutes was completed in a very small time span of 18 to 20 seconds. Then came third generation, fan beam and rotating detectors. Okay, now again this is the X-ray source with an angle of 30 degree to 50 degree. This is a complete fan beam, and this X-ray source can be rotated as well and throughout the human body. Okay, so if the fan beam is large, number of traverse motion of scanning frame is required, thus offering considerable improvement in measuring time. So if we are using a larger fan beam, okay, through which the X-rays can be produced, then number of traverse motion can be less. Okay, so pure rotational machine on this principle has been developed. The simplest of these have an X-ray source and a detector mounted on a common frame and rotated around position in 360 degree. Okay, again the improvement was, earlier we were only taking in 180 degrees. Now in this machine we could take an image of at an angle of 180 degrees. The fan beam which was used was 30 degrees to 50 degrees of the fan angle, and this complete device could be rotated 360 degree around a patient to observe whatever deficiencies are there in the body. Then came fourth generation, particularly a very expensive machine which we were using quite some time before. With the X-ray source, there is a sample and there is a stationary detector array. Okay, this is known as fan beam and fixed detectors. Okay, in order to overcome the difficulties encountered in rotating the detector configuration, a rotating machine has been designed in which X-ray source rotates with a foot circle station and of a stationary detectors and arranged around the patient. So the detectors completely cover or encircle the patients in all 360 degree directions, and the X-ray producing source or the fan source is rotated throughout the patient. So in each direction as the source is rotated, the opposite detectors observe and gather the information, which is then produces the complete image. The system employed as many as 200 detectors to maintain a good spatial resolution. However, the cost of such a system is very high, as detectors and their materials are very expensive. So these all were the detectors which were attached. The sample is placed here, and then this X-ray source is rotated throughout, and each of the opposite detector can detect or produce an image correspondingly. Then finally the most advanced 5th generation scanning electron beam. This is the system. Okay, this is known as scanning electron beam or SEB tomography. The SEB tomography, the electrode beam sweeps back and forth through the magnetic field. Okay, so this is the patient here, and these are the X-rays which swipe back and forth, and this is a detector array. Okay, the impact of electron beams on the semiconductor tungsten array underneath the patient generates X-ray, and X-ray detectors are mounted on the semicircle array above the patient. So this is the target on which tungsten beams are placed, and as they are headed they produce the X-rays, and this is the semicircular detector array placed over the patient. Okay, now X-rays and the impact of the electron beam on the semiconductor tungsten array underneath the patient generates X-ray, and X-ray detectors are mounted on semicircle array above the patient. Now since the electron beam can be moved back and forth through the magnetic field very quickly, time of scanning slice can be of order of 50 milliseconds. Now because of the magnetic field, these electron beams can be affected that are generate X-rays. Therefore the scanning time of such a machine is of the order of 50 milliseconds. Okay, this is for the present video. In the next video we are going to look at the processing unit, video unit and storage unit for CT scan machines. Thank you.